we're going to continue the ExCALIBUR theme with Dr. Ilektra-Christidi, who's a senior research software developer and particle physicist at the University College London. Ilektra, how are you today?
Hello, can you hear me?
Yes, I can. Thank you for stepping in today.
Yeah, so this presentation was supposed to be given by my colleague Thomas Koskela, but he's not feeling well today, so I'll be giving this presentation. Here we are.
It's in slide mode. We're good.
Good. So it's great that Martin gave the intro to ExCALIBUR, so I don't need to explain any context here. And I'll go straight into talking about how we're planning to and we're developing reproducible and representative benchmarks as part of the ExCALIBUR hardware and enabling software. So the goals of this benchmarking activity is, first of all, to develop a UK benchmark community of practice for ExCALIBUR, involving all the software projects, I'll call them the working groups, as well as test beds, as well as the other initiatives, to develop a set of benchmark good practices and approaches for ExCALIBUR, to provide support and coordination for these activities across the whole program, because it doesn't mean that researchers are familiar with any of this. And in more practical, technical terms, to develop a benchmark framework to allow to have all these benchmarks in one place that is easy to build and run in an automated way, and to collect performance data and do post-processing. And also to manage a suite of benchmarks that are appropriate to use on hardware testbeds and simulators and future pre-exascale systems. So as I said before, the things we do is to share best practices, build a community, and develop a framework for benchmarks. Things we do not do as part of this activity is to develop the actual benchmarks. This is the work of the developers of the software developers of the applications themselves. The domain experts know what are the benchmarks they want to see. We do not do the code performance analysis. Again, the developers will use our suite to do that. And we don't make procurement decisions, although the idea of this benchmark suite is that it would feed into informing procurement decisions. So as a first step, when this initiative started, to try to create a community, we sent out a survey to all the funded DDWGs, the design and development working groups, about very basic things, get to know their codes, what are the performance bottlenecks they have, what parallel models they're using, types of workloads, the amount of data, the I/O that they use, what computational methods are used in their algorithms, and such. And you see here a set of the answers. One thing to point out is that they're all over the place. And obviously the science case of ExCALIBUR is huge. You would not expect one bottleneck or one thing to stick out. Okay, almost everyone uses MPI. Okay, but that doesn't mean they're not interested in other things. Everyone wants more memory bandwidth and more compute, but it's not one thing. So it was obvious from that it wouldn't be that straightforward to put things in a nice neat box, which is fine. So how we evolved this community, and the person, I should say from the beginning, the person in charge of this is Andy Turner from EPCC. So we have regular meetings of this community where all the working groups presented their benchmarking plans, or maybe not even plans, maybe needs, maybe thoughts they had. They explained to us the performance bottlenecks, if they're using any proxy apps, what are they thinking about packaging them. And we went on to individual consultations, one-to-one with every group that presented. There have also been discussions on topics of interest, for example, algorithms and I/O, which is an issue that many people are worried about. and we've been giving updates from the technical benchmark team. We communicate via mailing list and a Slack channel, and there's details at the end of how to join those, pretty much contact Andy, and we'll be happy to include more ExCALIBUR people that are not aware of that yet. And we have a few working groups. So Martin alluded to a couple of those aspects already. There's one working group that is trying to identify, going back to first principles, to identify common algorithmic patterns between different applications and develop synthetic benchmarks to be able to explore the whole phase space between different implementation on architecture versus problem formulation, different domains. One example of that is they're looking right now is the linear solvers. And there's two very distinct domains that use them, and many more, the weather simulations and lattice QCD. And for now, they're looking into kind of a proof of concept that such a systematic study of algorithms can be done and can give us some insight. And they're looking into matrix-free solver implementation on a HPCG benchmark. Another group is going more into what we call traditional benchmarking. I don't know if that term is valid, is trying to see the science, the full science cases, the challenge problems that represent full science cases that different domains have. This approach borrows heavily from the ACP project. A lot, it's almost a copy, but it's a very good classification of how mature different applications are. And when you pose the questions, can you define a challenge problem that your software can solve on a petascale system right now? And then you categorize those into the answer into class 1 and class 2, depending if they already have such a problem. And if they don't, in the first case, we ask for a figure of merit and a performance baseline for this challenge problem. And then the question is how one scale the figure of merit to get to exascale. For the cases that such software does not exist yet, the question is how do you get to that point? And then the performance improvement, of course, cannot be measured against the baseline because that baseline doesn't exist. But you would ask what is the minimum needed to deliver some useful science at exascale. Again, we have collected, a call went out to the whole community, and about a dozen challenge problems were collected. And there's roughly an even split between class 1 and 2. That was a useful exercise because there's some common performance limitations emerged. And for example, that current algorithms, a problem is not any specific hardware, but the current algorithms have poor scaling, which means new algorithms need to be developed. And that better accelerator support was needed, large memory requirements per core, and better I/O. Moving on to the framework that I mentioned before. So we are building, we want to build a framework, a benchmark framework for automatic building, running, and analyzing these benchmarks. And we chose to use Spark for building and Reframe for running and data collection. So with Spark, the idea is that anyone who contributes a benchmark, they would contribute it as a Spark recipe, and push it to the Spark repository, so the app can be installed anywhere on any test bed or future system that has an up-to-date Spark. It would deal with dependencies automatically, and each system will have its own Spark environment. Reframe is a Python package that handles regression testing. So it has a configuration for every per application and for every system it would run on. It supports Spark in the latest version. Actually, contributed part of that back to Reframe. And in that way, the benchmarking results are collected in a consistent way. It can be post-processed and reproduced in a reliable way. And this is the repository, a snapshot of our repository where this framework lives. We have a UKRI ExCALIBUR organization, and for a given app, in this case, HPGMG, all the information needed to run this benchmark in a given system is in this Reframe config file. And there are guidelines about contributing to this framework. And there's two things one will want to contribute. You want to be able to run this on a new testbed, and there are instructions on how to do this, how to add new systems, and also how to contribute a new benchmark, in which case you need to give a Reframe config. So this is geared towards others contributed to that framework. And this repository has been inherited largely from Stack HPC, and there's already a suite of benchmarks that were used in the Rack 3 procurement there, as you see in that list. And we have added to that list HPGMG and Sombrero. And especially adding Sombrero was a very interesting exercise because it was done together with the developers of the benchmark itself. So it's kind of a prototype of how we would want people to put things in that suite. And eventually, I'm seeing the diverse needs and desires people have from a benchmarking framework. It will be a mix of proxy apps, mini apps, synthetics, and full applications as well, because not one of them is enough. Also, borrowing from the ECP project, we found some very good quality guidelines for proxy apps, if people want to contribute proxy apps. So in this other repository, there are some guidelines for specifically proxy app benchmarks. And the process of how to contribute to one, we're still working on it, but the idea is it will be streamlined via GitHub issue template, and there would be community review that if any benchmark follows these guidelines. So to conclude, it's very much a work in progress. It took a long time to pull all the strands together between meeting the whole community, seeing what everyone wanted from a benchmark suite, what everyone wanted to achieve, what they thought that suite would be. But I think at this point we have a decent reach, at least towards the design and development working groups. But more people are coming on board. So this is not a one-off exercise. We need to keep reaching out to other ExCALIBUR software projects. And as I said, it's difficult to identify simple problems that everyone has and solve one and that's done, or benchmark one aspect and everyone is happy with that. So there would be a mix of application and proxy and synthetic benchmarks. And since the people developing this were mostly RSCs, we're very much working towards good practices, documenting the environment you run, automate the deployment of this suite anywhere you want to run it, and the data collection and post-processing. Oh yeah, and for getting involved, this is, for getting an invitation to the Slack, you can contact Andy. We have a mailing list, and yeah, feel free to, it's a public repository, to contribute to this framework by opening an issue pull request in that framework. I think I finished earlier.
Yeah, you did. Thank you, Ilektra. Let's, while I wait to see if any questions are coming in, want to throw it up to the panel to see if they have any questions for you.
Yeah, so thanks, Ilektra. That was a really interesting talk. And two comments and then a question at the end. So I think you're towards the end there about the natural is really important, because it was certainly something we learned the course of the Dirac 3 procurements. As anyone at this meeting will tell you, it was everyone who was involved in that automation was really important. I think it's great that that's a key focus. And earlier we were talking about not making procurement decisions. Sorry, there's an echo. I don't know why that is.
Yeah.
About not making procurement decisions but having an influence. That was something I skipped over in my talk about Dirac 3, but the input from the RSEs, it was something that we built into the decision-making process, and it was extremely valuable because that's kind of at the core of the co-design process is having benchmarks and people who can interpret the results properly, as well as the researchers who can check the veracity of the results, but who can really understand the performance ones. That's key. So I had a question for people wanting to get involved. If someone has a code or an app that they think could be a benchmark, but they don't know SPAC and they don't know Reframe, is there support available to help with that bit? Because I'd say there'd be a lot of colleagues who have a code that they'd really like to submit to this, but might not know how.
Yeah, so once this framework is more mature, the plan is to organize training events, maybe demos online. We may make a little movie of it that people can watch, or even live hackathon style events where we can show people how to do that. That is a first step. And yeah, eventually, if there's a group that really is not willing to do any of that, but they want to be part of the framework, we could support to write a SPAC recipe, for example, or the Reframe config file. But especially Reframe is quite straightforward, so we would like to train people to do it.
Yeah, and it's probably good to broaden the base of people who are able to do benchmarks. Yeah.
Yep.
Thank you.
Well, I don't have any other questions that have come in, so thank you again, Ilektra, for stepping in. Appreciate that.
Thank you.